on the Isle of Wight in Ryde. If anybody knows anybody or is interested themselves, just drop me an email or something. My details will be up in a minute. If you No, it's 4 positions. You've broken it, haven't you?
Yeah, no, it's come out.
Okay, I'll let you off this time. Right, I've been told to hand some stuff out as well, so got t-shirts and this lovely lava lamp thing that we got from Redgate. Another 3 of them. So there we go. Right, I'm gonna do a high level sort of level 200-ish sort of session on Service Broker, the bits that go into making it up, the components, what they do, how they apply, so you can get an idea of how it sends messages around, so you can look to try and apply bits and pieces to it. Unfortunately, my hard drive with all my virtual machines on died, so I have no demos, I'm afraid, tonight, but I will put everything up online. So, who am I? I'm John. Hello. It's my email, Twitter, I'm the SQL Server Monkey. I've just started blogging again, many times. As for experience, I've been working with about 5 years now since I was working with you. Started off, wasn't it, Andy? I've started off with reporting services, doing some DBA stuff, did a bit of BI, a bit more BI, then landed as a DBA working here in Southampton, and now I'm a DBA on the Isle of Wight for a cosmetics company, which has a real bonus keeping the missus happy for the long hours. But, yeah, cheap cosmetics keeps the other half happy when I'm working till midnight. So, what am I going to? Of course. Okay, that's not a problem. Mark will have all of these slides and put them up on the SQLSoton website. What am I going to cover? Basically, it's like I say, it's a level 200 overview, what it is, the components, cover security at a high level, and how it sends messages and where they go, sort of internal to the instance, external to the instance, some of the bits and pieces, and ignore the demo bit, I'm afraid. So what is it? It's an asynchronous messaging system. So you've got point A, when you send a message to point B, it's here, off it goes, it will reach there at some point. It's a guaranteed delivery, so it will leave the primary instance or service, head on over there. Once it's been received at the far end, it will get an acknowledgement back. If it doesn't receive its acknowledgement, it will try to resend. The timescales sort of go from a couple of seconds to tens of seconds to minutes, and then it will keep retrying. I think it's every 64 minutes it will try again and again and again to send it, and it will live. The message will remain on the source instance until you either clear it down or it finally gets to the other end. It's contained within the database engine, so it's not an extra component you have to install or anything like that. You just need to do some configuration elements to it. It's all TC. Well, you can do it through the GUI, right click, do this, but it's easier. It's actually one of the things easier to do through T-SQL. It's a combination of some instance level components for some of the security and send and receive if you're going into an instance. And a lot of it is then contained within individual databases, which means obviously if you take a database backup, you get all of the configuration, so on and so forth, just backed up with your database from the very get-go. Transactionally consistent, so it's basically everything happens within a transaction. So you can begin transaction, do this. If it falls over, roll it back, and you end up in the same state you were beforehand. So you're receiving messages from the queue. Something fails, you can roll it back. It goes back there. Persistent, like I say, when you back it up, you back up your database, you back up everything with Service Broker, including all the messages that are living in that at that point in time. So, the components, what is it? Message types are the messages that are sent from point A to point B via whatever means. It's contracts which define who sends which message type, be it the initiator or the target. Queues, which is where messages are received to. So basically, when it's received, is in order. It's on the queue. I'll explain it in a moment. But the service which actually puts the message onto the queue. Routes, which is how to get there. Remote service bindings are used for dialog security, so that at a user level it will encrypt the message from the very source to the very end where it's received. And basically it says this user is allowed to send on this service effectively, so it's credentials, and it means that you can effectively send secure messages between SQL servers that are located in different domains, so on and so forth, that are not normally trusted, and endpoints, which are the send and receive components at the instance level. Right. Anyone got any questions so far? Cool. Right then. What have we got here? Message types. There is the definition of the message between the two service broker instances. There's different validation options. You've got none, which means put anything in there, send it, it'll be happy to receive it, and off it goes. Empty, which means it must be an empty message, which is things like end dialogues and so forth. There's no message payload effectively. Well-formed XML, so it must be a well-formed XML document within the message packet there. When you look at the queues, you will notice that everything is in var binary format, so you've got to sort of cast it back effectively. You can't see, you just select on the queue or receive into a variable. Unless you cast it to the appropriate data type, you're just going to see the var binary. And well-formed XML with a schema definition, which means if you've got schemas loaded into the SQL server, you can basically say it's coming as well-formed XML and it must conform to this schema that I've got here. If it doesn't do that, then you'll get an error on the message. Now, validation at the message level is performed inbound, so it's done by the receiving service broker instance. So you can send pretty much whatever you want to try, but the other end will say no thank you, it will come back. You can see a lot of the error messages, well, you see all the error messages. If the message hasn't received, at the other end will be in sys.transmission queue within the database that you're sending from. Okay. Anything at all? Right. And message types are used by the contracts object, which we'll come on to now. And essentially, the contract says, I'm going to, this side sends this message type, this side will send this message type. So you've got well-formed XML says I'm the data component part of this contract, and you can have another message type which is empty or none. Well, say it's an empty message type that comes back just as a confirmation based on the message type. So the message name is whatever acknowledgement, so that you can handle it with a stored procedure or so on and so forth, so that the application is aware of what's going on within that dialog. You can have one or many message types defined within the contract. So if you've got 4 or 5 different things, different actions you perform within it, so the initiator will send 3 different types of message that are all well-formed XML, or an empty one, based on what you're doing. I mean, one of the things I did was I put in well-formed XML sends my data to the other end, and an empty message simply comes, and then the initiator will send an empty message saying I've finished my transmit, at which point the target will go through processing the data, it will pick the empty one up, say, okay, not a problem, now I will end the dialogue that I've received all of the messages. Then it sends a message back, dialogue's closed, everything's happy. Certain system messages that don't require a contract, which are error, end dialogue timer, the end dialogue message. It's just the message name, which when you're handling it with stored procedures on the receiving end, I tend to look for the end dialogue in order to make sure I end it. But as I mentioned a minute ago, I have a specific message to say that I finished transmitting on this dialogue, so now it can be ended. So it's almost sort of three-way permit. And contracts are used by the services. Queues are where the messages are received into. It's kind of like a table in that it's got your columns and your rows. You can select from it. You can't do anything like an insert, an update, delete, what have you. All those actions are prohibited against the queue. You can configure it. So when you do a receive, typically you take the message off of the queue. You decrement the number of messages there by 1 and process it however you want to do it. You can configure it to say retain the messages until I end the dialogue. So depending on the type of processing, so if you need to go back in there and say, saves you writing a table, building a table that holds all of the history for the messages if you've got, say, a multi-part application that relies on having a confirmation to say, you've got an order service, is it in stock? Have we received payment for it? Can the shipper do it on time? And you storing that information externally, you can use the queue to retain it, check everything's there, select that information out, say that's fine, do what you need to do, close the dialogue down, at which point the queue will have those messages removed from it. Poison message handling can be configured at the queue level. Essentially what poison message handling is if when trying to do a receive, the queue hits 5 consecutive rollbacks, well, the receive statement has 5 consecutive rollbacks, it will turn the queue off effectively, and you'll get an event triggered saying something's not right, it's not working properly, come have a look at this. You can get around that, or you can turn it off, in which case it will just try what it's doing, fail, roll back, which will hang things and can be a pain in the bum to find at times. You can handle that effectively. I mean, I just offload everything into a processing table first, and I've got an ETL routine that goes through the table, processes what I need it to process, logs errors to the error table, and continues there where I negate the issue of poison messages there. There's other ways of handling it. If you look at things like Klaus Aschenbrenner, done a very, very, very good book on it for 2005 and 2008, SQL Server Pro Service Broker. It's got some interesting things there. Adam Mechanic's got some good stuff on it as well. I think Ben Gunn's got some blog posts. Yeah, we'll look at that. And you can use, got a feature called activation, whereby a message is received, a process is triggered, and it will automatically fire up a stored procedure if you specify it to. Say, when you receive a message, fire this stored proc. Now, there's a couple of different ways you can do it. One is you can have the process start up, then stick it in a while loop while 1 equals 1, go through the queue, pulling messages off of it, doing what you need to do processing wise. Other one is just do it, end, stop, next message, fires up, depending on how you want to do it. You can have a number of instances of the stored procedure come up in parallel, so the system can balance itself. So if you say you can have a maximum of 50 stored procedures of this stored procedure running at the same time, which means it will start pulling things off the queue, but it does lock the conversation, so you can't have one stored procedure start, lift the first message from a conversation, and then another stored procedure start and lift the second message. The first stored procedure will effectively, well, the service broker handles all of the locking at that conversation level, which means the stored procedure that has lifted the first message from that conversation will then pick the second one and through all like so. Well, the stored procedure will not process until it's got them all sorted in order. So you've got 3 conversations, each throwing stuff in. You lift you receive the first message whilst that's processing. You can't lift the second message until that's finished processing. So you can have you've got 3 stored procedures that will pick the 3 conversations out. So you're effectively looking at running things in parallel, but at the same time serially. Weird concept to do. Should have drawn a picture. usually used by services which come to you. You got a question at all, or go for it? Yes. Yes, I believe it can. You can also have activate external applications, but you have to write them to monitor for events. So message is received, it will trigger an event. You watch for the event, then you trigger your external application. You can't fire an exe through the activation feature, but you can, in a roundabout way, fire up the external system to pull it. But yeah, you can, if it's an object, if it's a stored procedure there, you can go execute this stored procedure as this security context. Go do. You can have one stored procedure that is activated for the queue, but multiple instances of that stored procedure if you configured it that way. Yes, that conversation will be locked whilst that message is being processed. Once that message has been processed and the stored procedure has finished what it's doing, then the next one can be picked up by a different stored procedure. But you can never have message 1 and message 2 being processed at the same time from the same conversation. Klaus's book does go into the locking element of it very, very well. It's probably the best. That's the one that I got my head around it using. It's well worth. I'll show you at the end. I've got the book on my PC. Should have. So is that? Mm. 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 Yeah. Mm-hmm. Yeah. Mm. If you put them in different conversations and different dialogues, yes. Sorry. Because as you receive it off the queue, it's not there anymore. Essentially, once you do receive top one into these variables, pull them out, process them, off it goes. Is normally how I do it. As I mentioned earlier, I've bodged some code into Oliver Hallengren's script to send the stuff to broker as well as its logging table. And essentially, what it does is for the backup process, I've got 10 databases. It's going to back up. It assigns a variable a GUID, passes that in as the dialog handle, and then it uses that dialog handle to send the confirmation information back to my repository, along with a now I've finished transmitting message, goes back as well at the end. So I've got stored procedures that pick that up. So I've set it up using 5 parallel stored procedures. So as the first one comes in, fires up the stored proc and off it goes. But it will only pull in for what's that server's. Come back to it at the end. That's all right. I've got some stuff on the laptop I'll run through if you want. But if you've got all of those have come in one conversation, whilst it's processing something, the rest of the stored procedure will be sat there twiddling their thumbs. Essentially, you batch it. Say you've got 100 records per conversation. Spin up 20 stored procedures. You'll have 20 conversations you'll be able to hit at the same time, and you just curse through them. If that makes any sense. Okay, services. Sends receive messages to the appropriate queue in the database. So you say, this is the service name, and I'm on top of this queue, so give me the message, and I'll put it here. And this is where the contract validation comes in. So you can say, I've got 4 contracts that this service is using, so I can receive any number of messages that are valid within the context of the contract, and I can receive, or I will send, this message as defined by the contract. So the initiators are only able to send, this is my data payload. Oh, excuse me. The other end is only able to send an okay, I've got it message, or I've processed it. remove it from any holding tables you've got, sort of thing, if that's the way your application is built. A lot of the logic is built outside of service broker in the context of you want it to perform something. So, like we'll come back to it in a minute. I've got some slides with demos and stuff on it. Well, not demos, sort of stuff we'll go through and see if it comes there. I say if there's no contract specified, then it can't receive, because obviously the contract message validation is done inbound, and if you haven't specified that the contract says I can receive this, I will only ever be able to send messages because I can't validate anything because I don't know anything about it. Routes. Specify the location of the remote service. You can use the NetBIOS name, the DNS name. If you've got a remote instance that's got the same service name on it, if you will, so you're listening, it's off there listening on its port, but you've got a multi-instance, you've got a multi-database environment where you've got the same service in each database, but say different customer databases, for example. Each database has a GUID assigned to its service broker instance. So if you assign, when you're creating the route, you say, this is where it is, it's on this machine, on this port, this is its service broker instance ID, means that you're not going to end up with it in the wrong database at the far end. Obviously you can configure security so that if you've got it that only certain users in the context of the system can send in or perform, but this makes life a little bit easier with regards to saying send it here, because what it can do is if it's got a bunch of services with the same, it does a best match when it picks which route it's going to send something when it receives a message. So it go, well, I've got 4 the same, I'll send it to that one, which is not really the best thing in the world. So it's just a case of the GUID you find in the sys databases, system catalog view. It's called service broker ID, I think, instance ID or something like that. I've got it down here. So yeah, specify the instance name. Best practice, specify the instance as well, so that the GUID, so it knows exactly where it's going. The TCP location and port, like I said, you've got the DNS name, NetBIOS name of the remote server, or you can specify an IP address, IPv4 or 6. Both perfectly valid. You say this IP address, colon, this bracket. When you're using IP version 6, make sure the IP address is in square brackets, otherwise it goes, no, I don't like this game anymore. Okay. And there's 3 different route types. Local means local route for local stuff, means internal to the instance. Receive it, it will find it, send it. Remote is exactly that. It's over there on that server, so send it out of the instance. Off it goes. And there's a special type called transport. Now, where you've got, say, 20 clients sending information to a single point, you don't want to have putting all of the routes in there and maintaining it. Say, it's 20 machines, I'm migrating this server, which means I've got to go back, change this route. You put a transport route in place, and then the name of your service at the initiator end, you say is a TCP : / IP address, DNS name is in your service name, and what it does when it's doing its acknowledgement, it knows where to send it back to because it looks at the service name. It says, that's where I'm sending it. Mladen Paradic, I don't know if I pronounced his name right, probably not, but on SQL Team has got some good articles describing an asynchronous auditing system that makes very good use of transport routes. So it's a very good practical implementation. He's got all the code there as well, so that's a good point of reference, that one. I've got all the links in the slide deck as well. But yeah, it reduces the management overhead if you've got, say, many initiator clients and a single repository to send the messages back. It means you've got less management overhead on the target instance with regards to managing your routes. You can run alter statements against the routes, so if you do move a server, it's quite easy. You just say alter route and reset the relevant parameters of the address of what you've got. Now, there are routes internal to MSDB. It's routing tables, and basically anything that's coming in from outside, it will check in MSDB to see if it's got a route to say where to send it, which comes back to saying if you don't specify name, it will go and look in MSDB and say, have I got an explicit route here to send this one to here? And if you've got multiple things, you can end up with stuff in the wrong database. So if you set a specific one that says the service is over here, is a local route, it'll come in, checks MSDB, sends it to the local service. But again, you need to specify your service broker instance. Any questions at all so far still? Got lava lamps to give away. See? Remote service bindings, as I said earlier, it's the credential for the dialog. So essentially what you're saying is that this named user, be it a Windows user or certificates, this one, sorry, it's transport security. The dialog, you encrypt it with take a certificate, create a user, authorize a certificate on a user, and basically that validates it at the other end. So if you've got initiate a target, you create the user, create a certificate, authorize the user, back the certificate up. So you've got the public key, move the certificate to here, create a certificate from the file, authorizing the user, which means that when this user sends a message to here, it will go, yes, I'm allowed to do so long as you've granted the relevant permissions at each end. If that makes any sense. I've got pictures later that make it a little bit more clear. So there's two security models there. You can use named or anonymous. So anonymous is exactly like that. You're basically saying, it is described there as you set your repository up, say, this is my certificate, which means when you create the other end, it's almost validating itself back. You can set up named users in each instance to send things, and you end up having to put certificates in both. So two certificates here, and you end up with a management overhead there, which can be quite unpleasant. Certificates, like I say, obviously make sure you've got a master key in your relevant database before you create them all. Otherwise it throws a big hissy fit. Endpoints. This is the instance level component, which is the TCP IP address it will listen on and the port number it will listen on for traffic. You can only have one service broker endpoint per SQL Server instance. Now, if you've got multiple instances on the same server, you can have an endpoint in each one, but the port you listen on has to be different for each instance, much like a standard connection endpoint. So you've got multiple instances, browser handles it. Here you've got to explicitly say listen on this one. Like I say, specifically, you can say listen on, if you've got multiple IP addresses on your server, you can say listen on this only on this IP address. So if you've got a certain network coming in that you want your traffic to come in on, say listen on that, ignore everything else, or all, which is the default one. Yes. How do you mean? The endpoint lives within SQL Server. It lives within the instance, and it obviously SQL Server clusterware, which means it bounces around between its nodes and off you go. Obviously it'll listen for service broker traffic. You can configure message forwarding here, so where you've got, say you've got external party here, DMZ, you'll put a message forwarder here, target's going to be back here, so it's almost a multi-hop sort of environment. You turn it on or off at the endpoint, so I'm allowed to forward messages or I'm not allowed to forward messages, and you can also set the message size that it will allow it to send. So obviously if you say you can send messages that are huge, you're going to take time to send messages, it's going to have an impact on performance and so on and so forth. I've not used that. I haven't found an application where I've had to. But with what my developers are doing, I might need to in future if they decide to stick a bunch of my SQL Server somewhere else. So those are the main components of just what we've got. Now, connection model. Basically, you grant connection to a user at the server level. So you create a login, and you grant that login permissions on your endpoint. Now, you can, if you've got a couple of SQL servers talking to each other, you grant the SQL Server service account that you're running each SQL server in connect permissions on the other one's endpoint. Because everything, the service broker lives in the database engine, which means it uses the context of the SQL Server service account when it's sending stuff there. You can set it up to use anonymous again, so you just grant connect to public, which will let anything connect to it. Or alternatively, you can, like I say, you set up the service accounts as for the remote server to connect to this one, and likewise, so you can send messages back to it. Typically, the default port is 4022. You can, in theory, use anything above 1024. So that's something to bear in mind if you've got to go through firewalls, so on and so forth. So transport security is a point-to-point security link between the instances, which is, like I said a minute ago, if you've got two instances, it will secure the message as it leaves instance 1, arrives at instance 2. I'll just clarify as well. When you're sending messages internal to SQL Server, it doesn't bother because it doesn't leave SQL Server. It just sits there. It knows it's secure. It knows when you're sending something outside of it. Obviously, your route says it's a remote route. Off it goes. Now, transport security means that you'll end up with a link. You can set it to encrypt messages, or you can encrypt the transport between point A and point B. Now, if you put, like I said earlier, you've got message forwarding it, you put a third one in the middle, it's encrypted whilst it's in transit from point A to point B. It gets decrypted at point B, which means if you read it off of sys transmission queue, you can get to the data. But then, whilst it's traveling to point C, it'll be encrypted again whilst it's on the wire. Which, depending on how your system's configured and how your security is set up, that could be acceptable, cannot be acceptable. Like I say, it's configured at the instance level with the endpoints. You can use Windows authentication for transport security, but you need to be in the same domain or a trusted domain, or otherwise you can use users and certificates. Certificate security say, I'm this person, honest, which means if you've got completely separate domains or SQL servers that are not normally trusted but you want to get messages between them, certificate security is the way to do it. Anyone got any questions so far? Encryption is optional. You can say encrypt, don't encrypt. It's RC4 and AS that it uses. You can. I don't really see a point in turning encryption off unless you want to do some troubleshooting with something, say like Wireshark, just to see what's going on, make sure things are going somewhere. So if you've got something spurious going on that you can't isolate through the system views and so on and so forth, maybe turn it off, but otherwise I tend to leave everything encrypted. Dialogue security, as I alluded to earlier, it effectively encrypts the message, which means broker instances as opposed to SQL Server instances. That's a something you want to differentiate with. The service broker instance, if you've got one or n number of hops, using dialogue security, your payload is encrypted across all of those hops. I've got a picture in mind that will show. It's configured at the database level with the remote service binding. So if you say send on create a dialogue with encryption, off you go. If you've not got a remote service binding, encryption won't work for dialogue. You've got to have the remote service binding in place to deal with the relevant security. And you'll get a nice little error message in sys transmission queue saying can't send this because your remote service bindings don't work properly. It is purely certificate for authentication, no Windows option here. And encryption is optional, like I say. Explicitly, at the statement level, when you send the message, you can say with encryption equals on, which means there's got to be a remote service binding there in order to send any messages. If you say encryption off, you don't need a remote service binding, it will send the data out. Now, there's two schools of thought with regards to handling the encryption here. Is developers always say off, and then the DBA can make a decision of, well, I want to put a remote service binding in, which means it will ignore the off and encrypt it anyway, and off it goes. So for ease, if your developer's always right with off, you can then control it as a DBA to say, actually, you know what, I'm going to encrypt it, and off you go, rather than them forcing your hand with a configuration at the database server level. So it depends on how you want to do it. I've convinced my developers to say off, which is awesome. Gives me a little bit more configuration leeway on the server itself. So here we go, pictures, which is how I managed to understand things a little bit better. We've got our initiator, we've got our target. Now, as I said earlier, transport security will encrypt once it's out to this bit here. It will be secure. Dialog security in this instance, same sort of thing. I don't tend to use dialog security because I've not got, as I say earlier, message forwarders. So we put the forwarder in. Transport security is, like I say, from point to point there, which means this bit here, not secure. So if someone gets in, reads a queue, potential if you've got sensitive data in their credit card, what have you. So you've got shop, forwarder, credit card service. Someone sneaks it there, then it could be a pain in the rear end for you. However, dialog security, all the way through, end-to-end security for that one, makes life a whole lot easier. There we go. Now, message sending. This is how messages go from point A to point B. Now, there's on the top there. This is internal to a single database, this one here. So what we do is we create, in this instance we've got a request and a response, two different message types. We've got a contract that then binds them together that says the initiator will send the request, the target will send the response. You build your initiator queue, and then your service to service the queue, your target queue, and your target service. So if you want to look at doing asynchronous transactions within the context of your database, you can do, depending on how you want your system to scale. I haven't encountered anything, but I haven't seen all of the myriad of systems that you can do out there. Anyway, T-SQL batch generates a message. That message moves to sys.transmission_queue. Just spelled right, Mr. Winner. That's where it will remain until it reaches the other end. So you can, if you've got a backlog back here, you can say I've got this many messages are affected. That's effectively you can view it as a buffer, if you will, of this is how many messages I'm still waiting to send from wherever I am. The target queue is this is how many messages I have received and have yet to process. Is the concept. Then you've got T-SQL receive command, takes it off the queue, and off it goes. So that T-SQL, you can either manually be doing it, or you can have a job that runs to fire a stored procedure or the batch of code, or you've got an activated stored procedure, or CLR procedure, or external activation. Then those are your options. And obviously then your T-SQL sends a response message. That will again go through the transmission queue to file service, received, wink, done. Message transaction done. Now if you send, at which point obviously if the initiator then says, oh, right, I'm done, end dialog, you'll end up with the system messages, the system end dialog message flowing through. So it will end the dialog here and it will end the dialog over here, which means no more messages can be sent or received on it. So if you try to send it on a dialog you've shut down, say no. Right, next model, into a database. So two databases, same instance. Similar sort of thing. As you can see, sys transmission queue is resident in the context of the database. So whilst you run it, it's there. You create your message types. So you create both message types in that initiator database, your queue and your service, you then create exactly the same ones here. So they've got the same definition. Contract has the same definition in this instance, and your queues, there we go, T-SQL puts it on there, it's received onto that queue, taken off the queue. The response batch fires, it stays, it moves, it is received, happy days. Inter instance, now I've got another slide after this which will show some of the stuff in the context outside of the database, but you essentially create your endpoint which is outside of your database, then it's exactly the same as it was for the inter database one. Everything's there, your batch fires that, off it goes, out through the endpoint, to the other endpoint, to the target queue, where it is received. Get your response batch, it goes, it sits there. So if you turn off the queue here, stop the endpoint, your message will sit there until it can be delivered. It will remain there until you clear it down manually or it is received on its wherever it is going. Like I say, send and receive on the endpoint, off it goes, received. So this is where you've got bits and pieces for the message sending inter instance. You've got your initiator service and everything behind it there. You've got your endpoint, which is created in the master database on both sides. So you create the root and the remote service binding saying, I'm going to connect to this target service on this server in this database, and this is the service name, and it's over there. Also, if you put a root, say MSDB, it says when you receive something, put it here, not anywhere else. And then you just mirror that configuration on the far side. So sends the message, it's the endpoint. Ooh, where am I going? Right, I'm going there. Ooh, there we go, sorry. It goes through, off it goes, finds it, arrives. And then the response comes back the other way if you've got whatever. So as you can see, that's the route that it takes logically. Yes. 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 I have read somewhere that there are licensing constraints if you're talking between SQL Server versions where something might have to be a paid for one, but I can't remember the detail of it because it was late at night and I was very tired. I've been hunting around for it. If I find it, I'll let you know. But I think that's in the context where you've got multiple hops and message forwarders and stuff like that. But it's Microsoft licensing. Best bet, speak to your licensing people. There's a few system views and DMVs that you can use to keep an eye on things. How am I doing for time, Mark? Because according to this, I got just over 5 minutes. Is that about right? Cool. Right. Broker connections is obviously what connections you're on. Forwarded messages. Each service broker message that is in the process of forwarding. So you've got stuff moving around. Have a look in there and you'll see what's activated tasks, stored procedures that are activated. So in your instance, that might be somewhere you want to have a look. See if you've only got one stored procedure or many sat there churning away on your queue, perhaps. I don't know if you've had a look in that one yet. The queue monitors is the number of monitors on that queue. So that's how many potential stored procedure instances you can fire up. So, how do you mean configurable? As in how many view? That is the activation option on the queue. Yes. Basically, when you set up your activation on the queue, you say you can fire up to this many stored procedure instances. That will say how many it thinks it can fire up. Yeah. When you're writing your stored procedure, if you've got an activated stored procedure, like I say, you can say whilst 1 equals 1, keep looking at this to try and receive stuff. But just be aware that if you do that and you start pulling nothing from the queue, you get to the end. You could have, unless you've done your error handling properly, you will go error, roll back, hit the queue 5 times. Poison message handling kicks in. Queue goes no, not going to play. Sys.services is the services that you have on your queue. Well, services for service broker. How many you've got within the database, what they're called. Routes, obviously, the name of the route and the information that you've got. Transmission queue is obviously everything that is being sent travels through it. If you're quick enough, when you do your send, if you've got a select from transmission queue and works on my laptop, you can essentially see, yep, there's a message, select from it again, and there's nothing there, you know it's gone fine. Obviously, you select again, and it will show you the error message. And service contracts for each contract as well. So you can have a look and see which message types it's sending and so on and so forth. And pull a lot of the information out from there. No demos, I'm afraid. Really annoying. But I'll put everything up online on my blog, hopefully this week. Resources that I found very, very useful. MSDN and TechNet. MSDN's got a number of tutorials there as well, along with demo code. It's very basic of copy, paste, run. This does some stuff. Very, very basic. No background around why you should be doing it, what it will do. Books online, best place to look. I say SQL Team, there's some really good articles that I used when I was learning. This is the book, I say there's 2 variants of it, the 2005 one and the 2008. There's a lot of crossover because it didn't really change too much. I don't think it's changed too much in 2012 either with regards to the capabilities within Broker. Although I was chatting with someone on Twitter the other day, and Microsoft, with some of the Connect items that he's logged, are alluding to things like monologues and so on and so forth. So potentially a lot more capability coming in future versions from what we've sort of got here, say. And some blogs. Denny Cherry, Alan White, and Adam Mechanic got some really good blogs on best practices for how to do bits and pieces, approaches to take with activated stored procedures and so on and so forth. Like I say, one of the things depends on if you're receiving large numbers of messages. There's a neat little trick that Klaus in his book demonstrates where you just do a batch receive, where you effectively receive everything off the queue in one hit into a processing table. And he did some testing on it. He said he get really, really good message throughput on the receiving end for that one. So there's some interesting ways of doing things. So I'm going to read. Is all I can say. Has anyone any questions? Oh, that's all right. Yes, it's in the database engine. Not really. You can use it to get information from point A to point B, but for bulk operations, I mean, if you're sending XML messages, the XML parser's got a performance overhead within the engine. You're probably more efficient pulling it out through SSIS. But if you want to do things in an async, I mean, one of the things that I've had to put in where I am at the moment is they want to track how long specific orders were at a specific order status. So rather than have them run an SSIS job every minute that hit the order table, which I really didn't like the sounds of, I had a poke around and thought maybe Service Broker, because that way trigger on the table, when it does whatever it needs to do, check it, find out what the status was before, what the status is then. Because one of the problems that we were going to face is if we ran SSIS, there's the potential that an order could change status twice in a very, very short period of time and we'd miss it. Trigger effectively sends the message out when the trigger fires, It sits there, it gets processed in, hits the table. We just run a pivot off of the table to say, this is the order number, this is how long it was at each status, and obviously we've got null values where it's not reached those status yet. But SSIs, if you want to shift lots of data, is the way that I do it. Sorry, go ahead. I haven't looked at that. I know, obviously, you've got mirroring endpoints and so on and so forth, but I haven't. I don't do any work with mirroring, so I couldn't really give you that information. It's not something I've had to look into, so sorry, I can't answer that. I don't know. Haven't got anything else until Mark turns up with the pizza. Or 2008, I think message priority came in with 2008. It's just assigned a generic priority if it's with 2005, if you're going across the versions. But yeah, you can assign a priority to a message to increase it. That's right. You can select against the queue object without doing a receive. The receive command pulls the message from the queue, but you can. You've got your queue, so it's a database object dbo.queuename or whatever schema name queuename, and you'd say select from to have a look at it. No, because you can't. You'd be looking at. You basically say they process the messages arrive in order, so and it will process them in that order. It's effectively priorities. Yeah, it's probably your easiest way, and that's like I say, I pull from the queue, put it into a table, and then just run an ETL job over the top of it for one of the other things I've done. I've not had any need to use priorities because everything I've got quick enough. We haven't got ridiculous throughput, so I can't answer it better than that. Pizza. Hey, perfect timing. No, right. You may. Yes, I'm going to give stuff away. Well, for your questions earlier, you do get your lava lamp. Has anyone got anything else they want to ask or? No? Right, okay. See if we can get to the pizza before Mark sets it up. I think is the order of the day. Or what? I'm hungry. I want to eat. Normally the first person up there. Thank you very much for your time. Appreciate you listening to me yabber on. I hope it's been of some use to you. I'm really sorry there's no demos, but I've now got an excuse to buy an external SSD, so I'm happy enough on that front. Thank you. D. I'm going to try and rattle through this. What time's pizza? Basically.